Could you, sorry, Doug, could you quickly go back one slide?
Yeah. So again, to start off, we need previously, this is our foundation of knowing how to calculate on a 45-degree right angle triangle, how to calculate the run, the rise, or the travel. We could use Pythagorean theorem. We could use the rise or run times 1.414, and it gives us an example there. So pretty straightforward. We know how to do this. We've been there. We've done that. And then this second slide that we have is all about naming the parts of the rolling offset. And we have in here the rise, the roll, the offset, the run, and lastly, the travel. So you can see how those are labeled, and we're going to continue on with this again. So when you calculate these rolling offsets, it's kind of helpful to visualize the offset in an ISO box. As you can see, when you have this ISO box, the travel goes from one corner to the other. It's the roll. That's what we call the roll across the front there. Ooh, and I went too far. So the pipe enters the bottom of the box and it cuts diagonally across, leaving the upper corner. So that's really how the rolling offset is. And in the pipe trades, there will be times where our offset will need to roll. And sometimes it has to go around an obstruction or whatever it is. So yeah, any questions on this slide, or pretty straightforward so far, yeah? Yeah, okay. So the next one we're going to go to is when 45s are used, the length of the run is equal to the length of the offset. And this is only for 45-degree rolling offsets, okay? Now, to calculate the travel, we would use that same constant as we would any 45-degree offset. We take the run or the offset, and we multiply it by 1.414. And that's how we get the travel. It works exactly the same. Now, to get the run and the offset is a little bit different. We just have to calculate that first before we multiply by 1.414. So if you are in the field and you're doing a rolling offset, one of the on-the-jobs method for calculating this is using the steel square method. And what we do is the rise length of the offset is laid out on a blade, and the roll length on the tongue, measure between the 2 points to get the offset. And once you have the offset, then you multiply by 1.414 to get the rolling offset. Okay, so this is right here, this last sentence in here, or the last two sentences. The rise length of the offset is laid out in a blade, and then you measure between the 2 points. So you see the measure where it says measure offset. So once we have the offset, then we multiply it by 1.414. Now, if you have bigger jobs, this is another on-the-job method for calculating larger offsets, is directly lay it out by using a square to ensure the rise and the roll form 90 degrees. So you can measure and mark out the lengths of the rise and the measure of the roll. And then once you get the distance between these 2 points, you can measure the offset. And the offset is the diagonal here. And then you multiply by 1.414 to get the travel. That's just another method of doing it. Now, in this particular situation, if 45-degree elbows are not used, Okay, if they're not used, we use Pythagorean theorem to calculate the offset. We take the rise and the roll, we square each of them, and then we square root it, and that will equal the offset. And then to calculate that, you multiply by 1.414. Oh, let me go back there. So as you can see, the roll is 6 and the rise is 8. Take a minute on your calculator and calculate what the offset is going to be. Can you do that for me? And that's simply done by taking 6 squared, adding 8 squared equals and shift square root. What is the offset in this little picture? Anybody just shout it out.
10.
It is 10. Thank you for that. Absolutely. It is 10. So we'll continue on now. And the next one is we're going to find the run, the offset, and travel using this drawing above. Okay. So the run or the offset, right? The run and the offset are equal in a 45 degree. If these are 45s being used, the run and the offset are equal. So we calculate that by 8 squared plus 6 squared. And that would be 64 plus 36 equals 100. And then you square root it. So the run or the offset is equal to 10 inches. And now to find the travel, we need to simply multiply that by 1.414. And our travel in this particular rolling offset is 14.14. The big note on there, if you're making notes, is these are 45s. This is the way to do it for 45 elbows. Any questions? Now, let's have a look at this one. We want to calculate the end-to-end measurement of the travel from the drawing. This is 45 degrees. These are 45s, and we have a fitting allowance of 22 mils.
Doug.
Yeah.
Sorry to interrupt. Could we
No,
go
no.
back a slide there?
You bet.
So where did we get where's the triangle we're working with in here?
You could see the 8 inches on the side measurement and the
Yeah.
6 inches. And if you draw a line across there, that would be the offset. You draw a line
Like this?
there. Right. And yes, exactly like that. And that's what we're calculating. We're calculating
see.
the offset or the run because with 45s, they are equal.
Okay, perfect.
Okay.
Alrighty, thanks, Doug.
No, that's good. Good question. Okay, so now with this particular example, we're going to calculate the end-to-end measurement of the travel. So these are 45 fittings. So we simply take the run or the offset is equal to the rise squared plus the roll squared. So let's do that math. There's 635 mils squared, 433 mils squared. And that equal, once you add these together, it equals 590714. Square root that, that is equal to the offset. It is also equal to the run because they're 45s. And now to get the travel, we simply multiply that by 1.414. Now it says my fitting allowance is 22 mils. So I minus off 2 fittings because there's 2 45s in here. And there you go, end-to-end measurement. And that I think is on your particular copy of this PowerPoint. I'm pretty sure.
Yeah, it is.
Yeah, it is. Okay. So this is just the way to calculate for rolling offsets when you have 45s. Is that clear? For 45s, this is the way to do it. Any questions? We'll do more examples a little bit later. Okay, the next one is when you do not have 45s. When you don't have 45s, you use the run squared plus the rise squared plus the roll squared. When you don't have 45s, you will be given 3 dimensions. And those 3 dimensions will be the run, the rise, and the roll. So this is the formula that you will use to calculate for 45 degree, or not 45, this is not 45 degree, when these are not 45s. So this is for unknown. Oh, this is not very good. Unknown angles. Okay, unknown angles. You use this formula. And if I go back to the other page, let me just take off that. This formula right here is when you have 45s. Okay, so there's 2 separate formulas, one for 45s and one for not 45s. And we use this one for not 45s. So that's the big part in this particular PowerPoint. So having said that, let's do this particular one. So listen, over here, it shows that we have a 51 degree angle, which is fine. So now we have to use the rise, the roll, and the run all together. The run, the rise, and the roll. And you will be given 3 measurements just like this. And you will calculate, you'll put your numbers in, 12 squared, 11 squared, plus 10 squared, comes out to that. And now there's the travel. This is how easy this is.
So does that 51 degrees not matter?
It does not matter, Kyle. If it is not 45s, you use this formula right here. You use, oh, let me just, you use this formula right here to calculate your travel. Okay.
Nice.
And the travel is this pipe right here, this pipe. So this is when you do not have 45s, right? If this angle is unknown, you use this formula and we will solve for everything on it.
Will they give you your run if it's not with 45s then?
Say that again, Devin, please.
They give you your run when it's not with using.
You will have 2 variables when you have the 45s, and you will have 3 variables when it's not a 45. How's that?
Good.
Okay. So let's go to the next, and we want to calculate it to the nearest 16th. So we have 19.1. So we take the 0.1 times it by 16. That equals 1.6. So it rounds up to 2, which gives us 2/16, which is 1/8. There it is. Okay, so that's just narrowing it down to a simple fraction.
What was that you said? The 2 variables is with 45?
Correct.
Okay. Learned it.
Okay. The next one, have a look at this one. So listen, we don't know what the angles are here, but did you recall I said earlier, if you don't know what, well, I didn't say if you don't know what the angle is, but if you don't know what the angle is, and if the run and the offset are equal, then you are having 45s. Okay, so we can figure out if the run and the offset are equal. So we'll just do the math. So the offset or the run if it's 45s, they should be equal. I have 1240 here in the run. Can everybody see the 1240 as a run here? There's 1240 as a run. So we're going to find out if those are equal. And what we do is we take 610, which is our roll, and then we take 1080, which is our rise, and we'll calculate that out. And look at that. If it comes out to 1240, right here, this came out to 1240. So because it came out to 1240 and our run is 1240, it means that I am using 45-degree elbows here. Okay, that means that I'm using 45s. So that's one way to determine if you actually are using 45s. And it appears that we are. So now we can simply multiply that by 1.414 to get our travel right there. Any questions? Pretty easy stuff, huh? Okay, so let's do a couple of more examples. Are you ready? Okay.
Yep.
I got this sheet right here. We're going to do a couple examples here. So I have 45s in here, right? It says right here, it says right in here that I have 45s. So having said that, take a minute and see if you can calculate the offset, the run, and the travel. So we have a rise of 95 centimeters and a roll of 50 centimeters. Somebody got that number? Well, I could write it out. Does anybody have that number available?
9,025.
What?
Oh, sorry.
Okay, so 9,025, and then we have to square root it.
Nope.
107.
Nope. Yep. Sorry. Nope.
No?
It's 11,525 to then.
Oh.
That was just the 95.
Okay. So combined, it was what? 11,000?
525.
There you go.
And then we square root that
107.
point
35.
7 even.
35. 107.35.
Okay. So that's 107.35 centimeters. What is my run then? They are the same in a 45-degree, right? They're the same, aren't they?
Yeah.
Yes.
And now the travel is calculated by taking 107.35 and multiplying it by 1.414 is equal to the travel. What is the travel equal to then?
151.8.
Excellent.
Okay.
Good work. Easy, huh? It's not too bad. Rolling offsets are simple. Let's have a look at this next one. So listen, I do not know my angle down here. It says a question mark, so it's not giving me the angle. So, but I have three variables here. Now, I want the answer in feet and inches to the nearest 16th of an inch. So I got to change all of these into feet. So my rise is going to equal 4.25 feet. My roll is going to equal to 3.5 feet. My run is going to equal to 5.3333 feet. And that's me just converting the inches into feet. I just did it for you there. And then we could write this out where we take the 4.25 squared plus the 3.5 squared plus the 5.3333 squared. And that equals, and if we square root that, that will equal the travel. And I think if you get the answer, it should be 7.66653 feet is the travel. So the answer is 7 feet, but I want it in feet and inches to the nearest 16th. So I'm going to take 0.66653, multiply it by 12 inches per foot.
I get 5.97 at 7.66653.
Say, oh, my numbers aren't matching yours?
Yeah, I used one less 3 than you. I only went 5.3.
Okay, so we're close enough, Jarrett. Okay, how's that? So what is this? It comes out to what? 8 inches. There we go. Matt, it should be 8 inches, 0.666 of a foot. Times that by 12, I think it comes out to 7.999, which is 8 inches. Yeah. Matt?
Yeah, you're right.
Thank you. I don't hear that enough. I mean, you know, I've been married for 30 years. So yeah, I need to hear that more. I need the affirmation. Okay. So now in the chat, in direct chat, please do number 7 for me. And then put your answer in the chat. Direct message me. Remember when I said if we're using 45s, the offset, once you have the offset, you simply multiply by 1.414. That's it. Too much information in there, right? Or that should be a 0. Yeah, no, that's right. So too much information in this question for a lot of people, yeah? Yes. But as you can see, if you did do this, if you took the rise and you went 1200 mils squared as the rise, and you added the 1600 squared of the roll and you square rooted it, that's going to equal 2000 millimeters. And then you times it by 1.414. Because it's 45s, the offset is equal to that. So there you go.
You don't even need to do that second step if it tells you that you're using 45 fittings.
Almost not. It gave us enough information that all we had to do was just that.
Oh, okay, that makes sense.
Yeah. Okay, I got another example for you here. Okay, in this example, I want to actually find out the length of this piece of pipe from here to here. I want this piece of pipe length. So I'm going to give you guys till 10 a.m. to see if you can figure this one out. Okay. Put your answer in the chat as a direct message to me. Okay, so these are 45-degree elbows. And we know if we take the roll squared and we add to that the rise squared, that equals the offset or the run. And as you can see, the run is right here. So if we take that right here and minus off 61, that would equal this. So we do that. So 12 squared, let me just do that. 12 squared plus 8 squared equals, and then shift square root. So the offset is equal to 14.42. And then we go 61 minus 14.42, and that equals 46.58. And that is this number right here. Just, okay. Oh, I didn't want to.